When we sketch planes in space, it can be hard to think about how to make it happen when we start with something that looks like this. We have three variables, they all equal something, and it can be hard to wrap your head around where to start and what to do. Because even if you solve for one variable, you still have two on the other side and you're juggling it. So it's not as quite as simple as thinking about lines in 2D, for instance. But one way to maybe simplify the process is to think about these 2D cross sections. What do I mean by 2D cross section? Well, what I'm saying is that we're going to think about only two variables at once, and we're going to fix the value for the third variable, and we're going to use that to kind of piece together what we're dealing with. So there's another way you could do this. I'm not necessarily recommending this, but you can find 3 points that just happen to fit in this, and you can hope that generates a plane. But that's error prone. There are other issues that come along with dealing with that. So let's go ahead and try this by doing this 2D cross section. So the first thing we're going to do is we're going to set the x value to 0. And we're going to set not only the x value equal to 0, we're going to set the y value equal to 0. So that would leave us only with that piece. So that tells me that z equals 2. So in this case, we're really not even doing 2D cross sections, but we could. So that tells me that z equals 2. So that tells me that the point 0, 0, 2 fits on the axis. 0, 0, 2, is a point in the plane. Is a point in the plane. Now let's try that with another variable. So let's set x equal to 0 and z equal to 0. So that tells me y equals 6, which tells me that 0, 6, 0 is a point in the plane. So if that's x and this is y and that's z, so 0, 1, 2, 3, 4, 5, 6, and 0 for z are all points. And then finally, I could say I'm going to set y equals 0 and z equals 0. So that equation tells me that x is 3, which tells me that 3, 0, 0 is a point in the plane. So you might ask yourself, you just heard me say that you can't just pick 3 random points in a plane, or 3 random points that fit and hope they work. Well, the reason you can't just pick 3 random points and hope they work is that you might end up with 3 points that are along the same line, so you don't actually end up with unique vectors and things like that. But the nice part about these is that you can, because you know that they're all in separate dimensions, you know that the vector from here to here and the vector from here to here can't be parallel, because the vector from here to here is going to have something that's not 0 in the first element. Something from here to here is going to have something that's not 0 in the second element, and it will have to be 0 in this element, and then the one from here to here have to be 0 in that element. So you know they're not parallel, which means you're always going to be able to, you're going to have enough uniqueness to actually draw the plane. So then if you put this together, you connect the lines. I'm doing this kind of poorly, but if you connect the lines from here to there, from there to there, and from there to there, you now have what is that plane. Now you can, you can continue to project that if you wanted to. Make that plane as large as you need to. But if you see that, what it is kind of looks like something that's leaned up against a wall. That's what that plane looks like. And there are other ways to do this. Some involve thinking this is, if you set one equal to 0, you could think about the other as a line, and you could have two lines, and then you could plot that way. But I find if you have this kind of equation, that finding 3 unique points with this method is one of the easier ways to generate a plane.